To further elaborate that light behaves as a probability wave, we consider single photon version of Young's double slit experiment. This experiment was carried out by Taylor in 1901, almost 1 century after the original Young's double slit experiment, which was performed in 1801. So in this experiment, the light source emits only one photon at a time, and surprisingly, we still observe interference fringes on the screen. This is indeed very surprising, and to discuss this, we are compelled to ask some questions, like if the photon moves to the apparatus one at a time, through which of the two slits does a given photon pass? How does a given photon even know that there is another slit? So we have a possibility for interference. And can a single photon somehow pass through both slits and interfere with itself? To answer these questions, we consider the single photon wide-angle version of this experiment carried out by uh, Menglai and Dales at the University of New Mexico. They consider a single photon source and two mirrors which behave like the two slits in the original Young experiment. Then we have a beam splitter, and after passing through the beam splitter, we observe the interference fringes at the detector D. So let's suppose that the molecules in the source emit a single photon at a time. So does that photon travels to path 1 or path 2, or can it move at both directions at once? No. However, if we consider that there are probability waves associated with a single photon, and as soon as the photon is emitted, the probability waves radiate in all directions from it. In this experiment, we will be only considering the waves, the probability waves that travel along path 1 and path 2, and then after reflecting from these two mirrors, we detect the interference fringes in the detector D. So this is only, we can explain it if we consider that as a single photon is emitted, probability waves radiate from it in all directions, uh, and that is why we observe the interference fringes, because the waves interfere with each other. So from the above discussion, we can conclude that light is emitted in the form of photons, light is absorbed in the form of photons. However, between the source and the detector, light travels as probability waves, and therefore wave nature and particle nature of light are inseparable. Thank you very much.